Hey guys, we're going to look at a couple new things today. The first being the area of a triangle that is not a right triangle, and the second being law of cosines. So in this first problem, we have the area of a triangle. We know that the area of a triangle is 1/2 base times height and what we're used to, but that works when you're able to have a right angle or able to draw a perpendicular bisector to have an altitude. So what happens if we have an oblique triangle? And here we have an oblique triangle. You can still draw the perpendicular bisector, and there are a couple ways depending on what you have, how you can figure things out. Sometimes if we had this piece and this piece, we could do Pythagorean theorem to find h. But since we only have the whole bit from a to b, we can use these formulas, which are just regular trig formulas, creating a right angle by drawing an altitude here. So in order to find the area of a triangle having two side lengths, 24 and 10, and let's just say this is b equals 10, and let's say this is c equals 24, and let's say included angle of 62 degrees, that's how this formula works. Whenever you have a side, an included angle, and a side, you can use this awesome formula, and it's really straightforward. It's just 1/2 whatever side you have times whatever other side you have times the sine of whatever angle you have. And you just put that right in your calculator and you get about 106 meters squared. This is a handy formula for all those standardized tests that you guys love to take. Just a good formula to remember when you don't have a right triangle. As long as you have a side, an included angle, and a side, you can use that formula. Okay, I just made that triangle really messy. All right, so now we have something called the law of cosines, and it is used when we have a triangle that is side, angle, side, or side, side, side. So these formulas look really gross, and the biggest problem that you're going to have is putting it in your calculator correctly, but otherwise, it's basically derived from the Pythagorean theorem, and it's pretty easy to use. Just don't get your steps messed up in your calculator. All right, so basically you can find the side length of a triangle by squaring the other two sides, subtracting 2 times that side, the other side, and the cosine of the angle. Sounds confusing, but let's look at it in terms of a picture. So if we have a side angle side triangle, we can use the law of cosines to find the side opposite the given angle. So we're going to do that as step 1. Then you'll use the law of sines for step 2. Then third step, you'll subtract the measure to get the third angle. All right, so we've got this triangle right here, side angle side, meaning we've got a side right here, an included angle, and another side. All right, so in this case, we are going to find the side opposite the given angle. So a squared, in this case, equals b squared plus c squared minus 2bc cosine of a. So we want a squared. We're going to put 20 squared plus 30 squared minus 2 times 20 times 30 cosine of 60. You don't need to memorize these formulas. It's literally a matter of take the side that you want, and then you're using the other two sides in the angle. So literally, you're going to plug this in your calculator as is, including all your parentheses and making sure that you're in degree mode. You get a squared equals 700, square root that, and you get about 26.5. Make that about 26.5. So we now know that a is 26.5, and that is step 1. Step 2 will be to use the law of sines to figure out what we need next. So if we want to find, let's say, angle B, we can do side B, which is 20, over sine of B, equals, we're going to leave it as square root of 700, which this is how we got A. A equals square root of 700, because that's just a more exact value and it's not rounded, over sine of 60 degrees. So we set up our ratios, and we have everything there. When we cross multiply and isolate sine of B, we get 0.6547. And so B, when you do inverse sine of that in your calculator, you get about 41 degrees. And then step 3, because now we know this is 41 degrees, so step 3 is just to take 180, subtract 60, subtract 41, and we end up with 79 degrees. So we've now found angle C, we found angle B, and we found side A. So you're still, quote, solving the triangle, meaning finding everything that's missing, and that's how you're going to go about it. So that's for a side angle side triangle. For a side triangle, we will use the law of cosines to find the angle opposite the longest side. Important. Then use the law of sines again, so that's always going to be step 2, and then step 3 will be the third angle, same thing that we just did. All right, so those are our steps. So here we have a side triangle, meaning we're given 3 sides, if you remember from geometry. That's all we've got. So our longest side is 9, so we're going to start by finding angle B. So we're going to use b squared equals a squared plus c squared minus 2ac cosine b. And in our case, we know b, so b squared, a squared, c squared, and it's always 2 minus those two numbers, minus 2 times those two numbers, and then cosine b. We are trying to find the angle here, so just be very careful with your order of operations. When you put this in your calculator, you should end up with cosine of b equals negative 29 over 48. All right? And when you put that in your calculator, you get about 53 degrees. But because cosine of b is negative, this has to be in quadrant 2. All right, which means we have an obtuse triangle, which you can see from the picture. So in order to find angle B, we have to do 180 minus 53 degrees, and we get 127 degrees. That is our angle B that we want to use. This is kind of thinking about reference angles and where things come in like that. All right, so we know that this is 127 degrees, and then we can pick any of the other ones. We could say 6 over sine of angle A equals, and now we know we have sine of 127. And when you do your math all out, sine A is about 0.5324. So inverse sine that in your calculator, and you get about 32 degrees. All right, so we have 2 angles right there, and what else do we need? We need the third angle. So we have 180 degrees minus 127 degrees minus 32 degrees, and we get 21 degrees, and that would be angle C. So we needed to find all 3 angles, and we did. So always use law of cosines first, then law of sines, then just subtract from 180. So step 3 will always be the easiest. All right, so our last problem is just an application of this. 2 airplanes leave an airport at the same time on different runways. One flies on the bearing of north 66 degrees west at 325 miles per hour. The other airplane flies on a bearing of south 26 degrees west at 300 miles per hour. How far apart will the airplanes be after 2 hours? And you can see, I went ahead and just copied the picture for you because this is a little tough to recognize if we haven't studied a lot with bearings. And in this case, we haven't, so we'll just look at it this way. If we know that this is 66 degrees and we know this is 26 degrees and this is a straight line, we can figure out angle B in here quite easily. It's just 180 minus 66 minus 26, and that equals 88 degrees, which equals angle B. All right, so looking at what we have side angle. We just found out that that's 88. And then we have this side. All right, so we have a side angle, side triangle. So we're going to go ahead and use our first set of steps that we used, which they're pretty much the same. we just go ahead and we're going to say we're going to look for b squared. All right, and we want b squared, which has the question mark next to it, 650 squared plus 600 squared minus 2 times 650 times 600 cosine 88. Running out of room. So you end up with b squared is 755,278. So b equals the square root of 755,278. And that is about 869 miles. So this is very much just an application of plugging into the formula and finding out, okay, how far away are these two airplanes after 2 hours? Well, there's their bearing, there's their distance, and then using law of cosines, we can figure out how far apart they are, and then we don't have to do anything else. All right, so there will be some practice for you in Schoology just to practice these formulas and see how